Question 9 is a solid question on differential calculus. So we're given an open container here with a height x meters and length y meters. We're told the volume is 36 meters cubed, and it says here that A of x is the outside surface area of the container, and we're asked to show that A of x equals this expression here. So in order to do this, we're going to have to, first of all, try and express y in terms of x, and the way that we can do that is through the volume up here, because we know that the volume, or v of x, is going to be x squared y, and we know that x squared y equals 36. So we can therefore express y in terms of x by rearranging this to get y is equal to 36 over x squared. So now when we come to look at a of x, we can see that the outside area is going to be, there are going to be two of these tiles here and this panel here. So it's going to be 2x squared, and then we can see in terms of the side panels, there's this side panel here, 1, this panel here, 2, and then this front panel here, 3. So that's going to be 3 lots of x, y, and we've just found that y is 36 over x squared. So we can substitute this in, and we end up with 2x squared plus, that's going to give us 108x over x squared. So that x will cancel out with that, and we are left with 2x squared plus 108 over x, which is what we're asked to show here. In part B then, we are asked to differentiate this. So let's just express that with rational exponents. So we can say that a of x is going to equal 2x squared plus 108x to the minus 1, just expressing this as a rational exponent. And therefore, differentiating that is going to give us 4x minus 108x to the minus 2. So that is the derivative. In part C then, we're told that given the outside surface area is a minimum, find the height of the container. So if we've got a minimum, then we know that the value of this will be equal to 0. So we can set 4x minus 108x to the minus 2 equal to 0. So that means that 4x is going to be equal to 108x to the minus 2, which we can write as 108 over x squared. I can rearrange that then to give me x cubed is going to be equal to 108 over 4, which is going to give me 27. So therefore, x is going to equal the cubed root of 27, which is going to equal 3. And I can check that it is a minimum by looking at points either side of it. So if I found the derivative a dash of 2 and substituted that in, it would give me a negative value, and similarly a dash of 4 to the right of it would give me a positive value. So because the signs are changing, I can confirm that that is indeed a minimum. In the final part then, we're told that Fred paints the outside of the container, and we know that a tin of paint covers a surface area of 10 meters squared and costs $20. Find the total cost of the tins needed to paint the container. So we know that the area was minimized when the height was 3, so we can find a of 3, which is going to give us 36 plus 18, which is going to give us 54 meters squared. So that's the area that needs to be painted. So if we take the area and divide it by 10, which is the area that 1 tin of paint will do, that will give us the total number of cans of paint we will need, which is 5.4. Obviously, therefore, we will need to actually buy 6 tins, so therefore 6 times 20 is going to give us a total cost of $120.